Welcome to Tech Lab by Sid. In this video we are going to discuss about version control in computer science. Version control is a system that monitors changes to files over time, enabling developers to record updates to their code. It provides a way to revisit previous versions and facilitates collaboration without risk of overwriting each other's work, essentially serving as a history tracker for all modifications made to a project. There are two main types of version control systems. Centralized Version Control System, or CVCS. In this system, a central server holds the codebase, and developers work with copies of it. Examples include Subversion and CVS. Distributed Version Control System, or DVCS. Each developer has a full copy of the repository and its history. Changes are initially made locally and then pushed to a remote server. Popular examples are Git and Mercurial. The main reasons to use version control include collaboration. Multiple people can contribute to the same project without overriding each other's work. Tracking history. Version control keeps a record of changes, allowing developers to review or revert to earlier versions. Backups. It ensures that work isn't lost due to accidental deletions or file corruption. Version control involves several key concepts to manage and track code changes effectively. Repository. A repository, or repo, stores the code and its version history. There are two types, a local repository on your computer and a remote repository, which is typically hosted on platforms like GitHub or GitLab. Commit. A commit captures a snapshot of your project at a specific moment, representing changes such as additions, deletions, or modifications. Each commit is identified by a unique hash and includes a commit message that describes the changes made. Branching. Branching enables the creation of separate development paths. Instead of directly altering the main codebase, you create a branch to work on new features or bug fixes. Once the work is completed, the branch can be merged back into the main branch. Merging. Merging combines changes from different branches. If both branches have modified the same code, conflicts may arise. Git attempts to automatically merge changes, but conflicts require manual resolution. Tagging. A tag is a reference to a specific point in the repository's history, often used to mark significant milestones such as version releases. CVCS. In Centralized Version Control Systems, a single central repository stores the entire project history. Developers work by checking out a copy of the project, making changes locally, and then committing those changes back to the central repository. Examples of CVCS. SVN, or Subversion. A widely used centralized system known for its simplicity and effectiveness. CVS, or Concurrent Versions System. An older, centralized system that has largely fallen out of use today. Key operations in CVCS. Checkout. This operation retrieves a working copy of the project from the central repository. Update. It synchronizes your local copy with the most recent changes from the central repository. Commit. When you commit, your changes are sent back to the central repository. Revert. This operation discards any local changes, resetting the files to the state of the last commit. Branching and merging. While branching and merging are possible in CVCS, they are generally more complex and less efficient compared to DVCS. DVCS. In Distributed Version Control Systems, every developer has a complete local repository that includes the entire project history. This setup allows developers to work offline, commit changes locally, and later push them to a shared remote repository. Examples of DVCS. Git. The most popular DVCS, known for its speed, flexibility, and advanced branching capabilities. Mercurial. A simpler alternative to Git, though it is less commonly used. Key operations in DVCS. Clone. Copies the entire repository, including its history, to your local machine. Fetch. Retrieves the latest changes from the remote repository without merging them into your working directory. Pull. Fetches changes from the remote repository and automatically merges them into your local branch. Push. Sends your local commits to the remote repository. Commit. Records changes in your local repository. Merge and rebase. Techniques for integrating changes from different branches into a unified version. Working with remote repositories. Remote repositories, such as those hosted on GitHub, facilitate sharing code among developers. Developers use fetch, pull, and push operations to synchronize their local repositories with the remote ones. Git. Installing Git. Git is compatible with all major operating systems and can be installed either via the command line or by using Git GUI Tools for a more user-friendly experience. Git Workflow. Working Directory. The directory where you make and modify your project files. Staging Area. Files that you've marked to be included in the next commit. Repository. The storage for your project's history, where all committed changes are kept. Basic Git commands. Git init. Initializes a new Git repository in your current directory. Git clone repo. Copies a remote repository to your local machine. Git add file. Stages a specific file, preparing it for inclusion in the next commit. Git commit-m message. Records the changes in the staging area with a descriptive message. Git status. Displays the current status of your working directory and staging area, showing uncommitted changes. Git log. Shows the history of commits in the repository, allowing you to view past changes. Types of tokenization. Branching and merging in Git. Branching allows developers to create separate paths for development. To create a new branch, use the command git branch name. To switch between branches, use git checkout branch name. Merging combines the changes from one branch into another. To merge changes from a specific branch into the current branch, use git merge branch name. Rebase. Rebase is an alternative to merging, which rewrites the commit history. Instead of merging two branches, rebase applies your changes on top of another branch, resulting in a cleaner and more linear project history. Undoing changes in Git. Git checkout file reverts changes made to a specific file and restores it to its last committed state. Git reset moves the head pointer to a previous state, allowing you to unstage or remove commits from the commit history. Git revert creates a new commit that undoes the changes from a previous commit, maintaining the history intact. Collaboration in Git. Working with remote repositories. To interact with remote repositories, the key commands are: clone copies a remote repository to your local machine. Fetch retrieves the latest changes from the remote repository but doesn't merge them. Pull fetches and merges changes from the remote repository into your local branch. Push sends your local commits to the remote repository. GitHub or GitLab. These platforms host Git repositories and offer additional collaboration tools such as pull requests, issue tracking, and continuous integration for smoother team workflows. Branching strategies. Git flow. a comprehensive branching model that helps manage feature development, releases, and hotfixes. It involves multiple long-lived branches like master, develop, and feature branches. GitHub Flow, a simplified workflow where developers create branches for individual features or fixes, then submit pull requests for code review and integration into the main branch. Collaborating with pull requests. A pull request is a formal request to merge your changes into the shared repository. PRs serve as a platform for code review, discussion, and approval before changes are merged into the main project. Forking. Forking allows you to create a personal copy of someone else's repository. You can make changes to your fork and then submit pull requests to propose those changes to the original project, enabling collaboration on open source projects or other shared codebases. Here are some advanced Git concepts. Stashing changes. Git allows you to temporarily stash changes that you are not ready to commit. This is helpful when you need to switch tasks or branches but don't want to commit incomplete work. You can retrieve these stashed changes later when you are ready to continue. Git hooks. Git hooks are scripts that run at various points in the Git workflow, such as before committing or after pushing changes. They automate tasks like running tests, checking code style, or other custom processes to ensure code quality before committing changes. Git submodules. Git submodules let you manage repositories inside other repositories. They are particularly useful for handling dependencies or external projects that have their own version control. Changes to submodules are tracked separately, but they remain part of the main project. Working with large repositories. Git LFS, or large file storage, is a tool designed to manage large files, example, media files or binaries, that are too large to be efficiently stored directly in Git repositories. Git LFS stores the large files outside the main Git repository, linking them via pointers, thus maintaining performance while handling large files. Version control best practices. Commit message guidelines. Commit messages should be clear and concise. A good commit message explains why the changes were made and what was changed, providing context for future reference. A typical format includes a short summary, 50 characters or less, followed by a detailed description if necessary. Branch naming conventions. Branch names should be descriptive and reflect the purpose of the branch. For example, use names like feature/login-page for new features or bugfix/fix-login-error for bug fixes. This helps team members easily understand the focus of each branch. Avoiding large commits. It's best to make small, logical commits rather than large ones. This practice makes the project history easier to follow and helps to isolate issues more effectively. It also reduces the chance of introducing bugs when changes are integrated. Pull requests and code review workflow. Pull requests should always be peer-reviewed before merging into the main branch. Code reviews ensure that the code meets quality standards, is bug-free, and follows the project's guidelines. Managing merge conflicts. Preventing conflicts. To avoid conflicts, developers should regularly pull changes from the remote repository to stay up to date with others' work. Resolving conflicts. When conflicts arise, Git provides conflict markers to identify the conflicting areas. Merge tools can help resolve conflicts efficiently, ensuring smooth integration of changes. GUI Tools for Version Control. Git GUIs. Graphical user interfaces such as GitHub Desktop, SourceTree, and GitRackon simplify Git usage, especially for beginners. These tools provide a visual interface for performing Git operations like committing, branching, and merging, eliminating the need to memorize command-line commands. Git integration in IDE. Many integrated development environments like VS Code, IntelliJ IDEA, and Eclipse come with built-in Git integration. This allows developers to manage version control directly within the IDE, making it easier to perform Git operations such as staging changes, committing, and reviewing history without switching to a separate tool. Continuous integration and continuous deployment. Introduction to CI/CD. CI/CD pipelines automate the process of testing and deploying code changes. This ensures that every code change is automatically tested for errors and deployed to production without manual intervention, enabling faster and more reliable development cycles. Version control in CI/CD pipelines. CI/CD tools like Jenkins, Travis CI, and Circle CI integrate with Git repositories to automate the build, test, and deployment processes. When developers push changes to a Git repository, these tools automatically trigger the pipeline to run tests and deploy the updated code, ensuring a seamless workflow. Some other version control systems are Mercurial. Mercurial is a distributed version control system similar to Git but simpler and less widely adopted. Like Git, Mercurial supports basic version control concepts such as commits, branches, and merges, but it is designed to be easier to use for beginners or smaller teams. Perforce. Perforce is often used in large-scale enterprise environments, particularly when dealing with very large codebases. Unlike Git and Mercurial, which are distributed, Perforce is more centralized. It allows organizations to manage large amounts of data and code efficiently, making it suitable for industries like gaming or software that handle large binary assets. Troubleshooting and maintenance. Fixing merge conflicts. Merge conflicts occur when changes in different branches conflict with each other. To resolve these conflicts, you must manually edit the affected files to decide which changes should be kept. Once resolved, you can commit the merged changes to finalize the process. Recovering from mistakes. If you make a mistake or lose commits, you can use Git reflog to view the history of all changes, including those that are no longer part of the current branch. This allows you to recover lost commits or revert to previous states of your project. Repository maintenance. To keep your repository in good condition and optimize its performance, regularly run commands like git gc, that is, garbage collection. This helps clean up unnecessary files and optimize the repository by removing old or unreachable objects, improving efficiency. In conclusion, version control is an essential tool in modern software development, providing a structured way to collaborate, track changes, and maintain project integrity. By mastering core concepts such as repositories, commits, branching, merging, and following best practices, developers can streamline workflows, maintain clear project histories, and avoid costly errors. Tools like Git and platforms like GitHub and GitLab have transformed version control by offering powerful features such as distributed workflows, pull requests, and seamless automation integration. These tools enable teams to collaborate effectively, regardless of size, and ensure smoother project management. Whether working independently or as part of a team, understanding and applying version control principles is key to ensuring code quality, fostering collaboration, and managing both small and large projects with ease. Thanks for watching the video. Be sure to explore our channel for more content like this.